Christmas edition. So we had stopped on 12 grams. We had stopped on this statement. Then continuing, what of 1 gram of carbon? 1 gram of carbon produces, we shall have 6.02 times 10 power 23 over 12 molecules of carbon dioxide. Then what of the 56 grams of carbon in question? 56 grams of carbon in question produce, so we multiply this fraction, we multiply this times 56 molecules of carbon dioxide, and computing this, we obtain the same answer as before. 2.81 times 10 power 24 molecules of carbon dioxide. So this is item 8, Roman 1. Then item 8, Roman 2, a moment to take you back to our question. The question, Roman 1 required molecules of carbon dioxide produced. Then Roman 2, atoms present in carbon dioxide formed. This required number of atoms present in carbon dioxide formed. Therefore, since it requires number of atoms, we shall have the following. We have seen this one. So since it requires atoms present in carbon dioxide formed, we shall use mass of carbon because the item provides mass of carbon. So we take mass of carbon to moles of carbon, use moles of carbon to obtain moles of carbon dioxide, use moles of carbon dioxide to find number of oxygen atoms. So the item requires atoms present in carbon dioxide. Therefore, since it wants atoms present in carbon dioxide, we note the following. We note that one carbon dioxide molecule, one carbon dioxide like this, has what? One carbon dioxide has one carbon. Hope you are seeing. It has one carbon and 2 oxygens. It has 2 different atoms, carbon and 2 oxygens. Therefore, one molecule of carbon dioxide has 1 carbon atom and 2 oxygen atoms. So implying that in this case, we find number of oxygen atoms independently. After that, we also find number of carbon atoms independently. Hope you've seen where the difference is for this item. So we shall say that we know from Roman 1 that moles of carbon dioxide have been calculated. We have seen that they were 4.667 moles. So we first determine number of oxygen atoms, then later on we find number of carbon atoms. So what shall we say? So from this information, we have seen that 1 mole of carbon dioxide has 2 moles of oxygen atoms. 1 carbon dioxide has 2 oxygen atoms. Therefore, 1 mole of carbon dioxide is equal to 2 moles of oxygen atoms. Then what of the 4.667 moles of carbon dioxide which we have? This will be equal to 2 times 4.667 moles of oxygen atoms. And computing this, we obtain 9.334 moles of oxygen atoms. Then to find number of oxygen atoms, these are moles of oxygen atoms. They are not number of oxygen atoms. Then to find number of oxygen atoms, we know that we apply this relation. 1 mole of oxygen atom is equal to 6.02 times 10 power 23 atoms. Then what of the 9.33 moles which we have obtained, moles of oxygen atoms? This now, if 1 mole is equal to this, then 9.334 moles will be equal to 9.334 times 6.02 times 10 power 23 atoms. And computing this, we obtain 5.62 times 10 power 24 atoms of oxygen. Hope you've seen where the difference is, the difference between Roman 1 and Roman 2. Roman 1 required molecules. Here we want atoms present in atoms present in carbon dioxide. And carbon dioxide has what? Has 1 carbon atom. It is here. It also has 2 oxygen atoms. So in this approach, we have started with atoms of oxygen. You have to find atoms of oxygen and atoms of carbon. So here we have calculated atoms of oxygen. Next, we calculate atoms of carbon. Still, we shall have this pathway. Then here we want number of carbon atoms. This is still under item 8, Roman 2. So for number of carbon atoms, we note that one carbon dioxide molecule has one carbon atom, and 2 oxygen atoms. However, for oxygen atoms, we have already calculated that. Now, in this case, we deal with number of carbon atoms. So one carbon dioxide molecule has one carbon atom. What do we say? Before we say anything, this is what we know. We know that the moles of carbon dioxide are known as 4.667 moles. Therefore, 1 mole of carbon dioxide is equal to 1 mole of carbon atoms, as in 1 mole of carbon dioxide has 1 mole of carbon atoms. Since we know that, then what of the 4.667 moles of carbon dioxide? If 1 mole of carbon dioxide has 1 mole of carbon atoms, then what of these moles? These moles will have 1 times 4.667 moles of carbon atoms, and we obtain 4.667 moles of carbon atoms. These are moles. Now we find the actual number of carbon atoms. What do we use? We use 1 mole of carbon atom is equal to 6.02 times 10 power 23 atoms. Then what of the calculated 4.667 moles? These moles will equal to these moles will equal to we multiply will equal to 4.667 times 6.02 times 10 power 23 atoms. And calculating this, we obtain 2.81 times 10 power 24 atoms of carbon dioxide. Atoms of carbon, not carbon dioxide, sorry. These are atoms of carbon. So this is item 8, Roman 2. Hope you've taken note of it. Then we proceed with item 9 in our next video.